Good morning, this is Tom from San Diego, dealing with Every Step Calculus, Every Step Physics.com. Let's do another one of these worthless Taylor series problems. Like all of calculus, solves nothing useful, and this is a prime example of that, and I'll get into it as I do the problem. This kid puts in here for please help with Taylor polynomial. Find the Taylor polynomial of orders 1, 0, 1, 2, and 3 generated by f at a for f of x equals log of 1 plus x, a equals 0. Pretty clear, huh? You could do that in your sleep, couldn't you? I don't think so. But let's us do it. Index 8 to get to my main menu. It's Taylor series is what we're after. That's the subject, so that would be in my menu. Taylor series. I'm going to go down to the bottom of the alphabet by going up with the cursor here to the T section, and I'm going to find Taylor. Here's Taylor and Maclaurin, and I'm going to choose number 2 Taylor series here, because that's what we're doing. We're not doing the coefficients, we're not doing the ratio tests, we're not doing Maclaurin. Maclaurin is just actually this is the actual Maclaurin series because it is a equals 0. That's the difference between Maclaurin and Taylor, is a equals 0. Okay, we're going to choose number 2, numbers before the problem, or you can scroll to it. You can scroll to it with this, or you can just push the number 2. I always give you the formula so that you can write down the formula, because that's 2 points on a test, 3 points on a test. If you can do that, you're on your way to getting some points on a problem. And then in case they ask you for the Taylor series summation notation, this is what you would put down in your notes or your test. Okay, we're going to enter the function. We have to press alpha first in my programs before you enter anything in these lines here. Okay, and the problem is log of 1 plus x, so we're going to press the second here, and that's number x, which is the log. I'm going to put 1 plus x, and here close off the parentheses, and we're going to press alpha and 0 for the a equals. A is alpha, and alpha is a point on the curve if you graph the function, which is very close to the actual slope point. Remember, a derivative is a slope of a line. That's it. Okay, so we've put in our function here and our a, and I say it's okay, so I give you a chance to change it in case you didn't put it in correctly. So press number 1. We're going to find the succeeding derivatives. Now you can do that, can't you? Notice f of x is log of x plus 1. Anytime you see this, the first derivative is always 1 over x plus 1, right? And the integral is the opposite of that. In other words, if you ever see in a problem they want to integrate 1 over a quantity in the divisor here, you're going to put log of x plus 1 every single time. Okay, so you have to memorize things like that. Now notice that when this person did the derivatives, he switched the divisor into the numerator and changed the exponent to negative in every case. Okay, so that's the tricks that he's using. Now you notice that he wanted help, this person wanted help with finding the Taylor polynomial, but is this help? Does this help you? Look at this stuff here. And then it always annoys me when they say, I hope this helps. In other words, I'm really a brilliant person. This was a snap for me. I put this down in 2 seconds. I can do all these problems like nothing. And you're stupid, you can't do anything. So I hope this helps. Yeah, well, it didn't help. It didn't tell you you couldn't do anything on here the second time or third time in case you had a test tomorrow on this problem or anything else. With my programs, since I study this crap and try to figure out what these people are doing, and I've done that, and these takes me sometimes weeks to figure out what the heck's going on here and how to do it in a systematic way, because I have to program the calculations in this calculator. I can't just put down these things here. I have to do the math on it. Well, then you have to figure out what the system for the math is, and that's what I do here, okay? Now notice here's the second derivative, f, double prime x here. You notice that if you put the -2 up here, you get a -2 for the exponent, and -2 times 1 is, you multiply the exponent times the front of the problem. -2 times 1 is -2, and then you subtract 1 from the exponent, so that's -3. And then here we go. Now these are all, I've all put these in I haven't changed these to the numerator because you don't need to. This is doing the derivatives for you. Now this is asking, the problem is asking for only the 0 to 3. So here's where you would end up on your sheet here on this problem. So we've done the derivatives. Now we're going to compute the derivatives with a equals x, or f of x equals f of a equals f of 0. All right? So now we're going to take 0 and we're going to plug it into every one of these derivatives. For instance, here's log of 1 plus 0 is log of 0. The log of 0 is 0, okay? Now when you put 0 in for x here, 1 plus 0 is 1 to the -1 exponent, and that turns out to be 1. Well, we're doing that in the next sheet here, okay? So we did and here's the third derivative, which is 2. Exactly what he got here, okay? Now we're going to sub into the formula, the first formula that I showed you in this program. So we're going to sub, here they are out here, 0, 1, -1, 2, and -6 here for the, I've done 4, and you're doing 3 because of this problem, okay? So here's where you end up. And put in the factorials, that's the part of the formula. Now we're going to calculate the factorials times the derivatives in front. So we're going to take the factorials times these in front here, these numbers here in front. And when we do that, it turns out to be these answers here. Okay? Now notice the complication of all this. Notice how you have to remember to do this, and then you'd have to, within 5 minutes doing a problem in a test, be able to flop this down on your test. And then you realize it's all complete nonsense. It's complete useless. Just going through a waste of time, So we've done that now. We've multiplied here's factorials are 1 times 2 times 3 times 4 times 5, which is really 120. And of course, 24 divided by 120 is 1/5. Now we're going to complete the formula again, which is the answer. Equals x plus minus x squared. Now that's what he's got here, right? Or she, whoever wrote this. X squared plus x cubed over 3. Here's we go for the first 3. Here's what you'd put down in your paper. Now my point is that after researching on YouTube, where many professors, and every one of those professors on the YouTube is getting 18,000 views or 6,000 views or something. I'll get 3 on this fabulous video right here. I'll get 3. This month I'll get 3. You could help that by sending it to your friends, but of course you won't do that. You could subscribe. That helps a little bit. But they keep me out of the limelight because I don't teach calculus. I put it down. I'm totally against teaching or having calculus be taught in college to anybody, including engineers or anything. Without calculus, we would have still had our space exploration. We still put a man on the moon. Not one calculation is done with all that stuff. Believe me, I know what I'm talking about here. Nothing in medicine, nothing in electronics. I'm an electronics major. Never did any derivatives or integrals in electronics calculations for coils and capacitors and resistance and all that. You certainly use Ohm's law, that's for sure. So here's the answer, but now look what we found. This is a series. Now what? And every professor will come up on the blackboard and you'll end up with this, and then they'll say, well, class over, thank you very much, but not for you and me. What does this all mean? What does this all mean? You're going to add this. What are you going to put something in for x here and then add these all up and come up with a number? Well, I've done that. If you take this and put x equals 2, the answer becomes 5.07, okay? Great. Now you would expect that would converge to 5 or something like that, some one number, but it doesn't. You put x at equals 3 and the answer is 35.9. You put x equals 4 and it turns out to be 158. You put x equals 5 and it turns out to be 503. So what are you solving here? What are you coming up with? And this is adding these all together with x equals 5, 2, or 3, or whatever I put in here. These are always the questions that I go through because you're trying to find some rational system for whatever they're talking about. This is all for mathematics, and let them deal with this stuff, not us, you know. But anyways, those questions, what this all means right here, and Taylor, of course, you know, thought it up, of course, and insanely at night. I don't know why he would even think about doing this stuff, but anyways, he did it. So invented it probably in the 1680s, like Newton, and who invented calculus, and Leibniz, who invented calculus in 1680. A lot of mathematics was done in the 1600s and early 1700s. And Newton and Leibniz were working on exponents, you know, and yet they're attributed for inventing calculus. So anyways, go to my site, you know, buy my programs and pass calculus. It's as simple as that, you know. And share this with somebody so that I can get some more views. Okay, maybe with your help I can get maybe 5 views this month on this video, okay? But you have a good one, okay? Good luck in your calculus. And of course, if you buy my programs, I help you. Call me up on the phone. Or you can send me your tests or quizzes. I'll show you how my programs work on those things and help you all I can to pass calculus. So I'm all for you. Have a good one, okay?